Okay, into our second topic for the year, electricity and magnetism. And the first subtopic we're going to look at is electric fields. And in this first video, part A, we're going to review the concept of charge, which most of you hopefully covered last year. And we're going to look at Coulomb's law, which you may or may not have looked at last year. Why are we interested in electricity and magnetism? Well, to be honest, the reasons are just way too numerous. But just to give a few that may be interesting and maybe relate to things you're familiar with or things that you're seeing both in other parts of physics or in maybe chemistry and some of the other topics that you're doing. To understand the atom and what holds the atom together, we need to have an understanding of the concept of electric charge. To understand bonding between atoms and between molecules and all that sort of thing, it all relies on the concept of electrostatic interactions. So, we're using this stuff on electric fields and charge when we're talking about any type of chemical bonding if we're doing chemistry. Electromagnetic communication, whether it's our televisions or our mobile phones, all relies on the transmission of electromagnetic waves which create electric fields in antennas, which is how signals get transferred to our phones and our televisions and all of our devices. Printers, photocopiers, all make use of electric fields to print, to transfer ink from, some sort of cartridge or some sort of drum onto bits of paper. We're going to talk about particle accelerators that are used to study, to do scientific research, but also are used in medicine. Metal detectors is another one which, are used now not only for people out looking for gold, but are used by people who want to, they're used in scanners at airports, and they're used in mine detectors within the armed forces and things like that. So, the list is endless of the applications of electricity and magnetism. It's really important physics. So to understand electricity and magnetism, we really need to start with the concept of what is charge. So we know, hopefully, all objects are made of protons, electrons and neutrons, that protons have a positive charge and electrons have a negative charge. Now, in most cases, the net charge on an object is zero. The amount of positive charge and the amount of negative charge are equal, and an object doesn't have what we call a net charge. But we can easily create the movement of charge to create charge, and there's lots of ways that we can do that. So I guess this first part, I'm going to review what I would normally teach in Year 11 is what I call the charging mechanisms. So what are some of the ways that we can create a charged object? Now, you've probably hopefully all seen it done with a Van de Graaff generator, and I could have used a Van de Graaff generator, but I'm going to use something a little bit simpler, and it's something that you can all easily do yourselves. You could probably do at home. You might even want to do this, just to impress your friends at a party or to impress your mum and dad at the dinner table. So let's look at some of the charging mechanisms now. Okay, so let's look at the charging mechanisms with my improvised Van de Graaff generator, also known as a balloon. And I'm going to charge this balloon up by rubbing it on my hair. So I'm going to use rubbing as a way to charge it up. Just to show that at the moment we hold this balloon above these bits of paper, nothing happens, it's not charged yet, there's no trick or magic. So, let's charge up the balloon. So a Van de Graaff generator charges up the top of it by rubbing the belt, rubbing against the pulley, so it also uses a rubbing mechanism. And then after we charge this up, we'll hold it above the paper, and we can see all our bits of paper dancing away. So what's happening? Well, the first thing that's happening, let's try and get rid of them. The first thing that's happening is what we call charging by induction. Because this paper, a bit of paper doesn't initially have a charge, but when the balloon, and we'll say the balloon just has a positive charge, it doesn't matter. As the balloon gets nearer, the balloon causes all the positive charges that can move in this paper to get pushed away, and it causes the top bit of the paper, to get left with a negative charge. So all the positive, if you like, could get pushed away, the negatives all at the top. The opposite charges then attract, so the bit of paper jumps up. So that's the first charging mechanism, charging by induction. Then, once the bit of paper gets to the balloon, it's in contact with it. So what can happen is we can get charging by conduction. The charge moves onto the bit of paper. So now if there's a positive charge on this balloon, there's also a positive charge on the paper. Some of the positive charge from the balloon moves to the paper. Then they have a like charge, they have the same charge, so then it repels. So that's why it jumps up, touches the balloon, and then they tend to want to jump off. That's, if you like, rubbing, first charging mechanism to get charge on the balloon. Induction, which is what charges up the bit of paper initially and causes it to jump. Conduction, which gives it the same charge as the balloon, repels, and it pushes the bit of paper away. Okay, just one more example of charging by conduction. We've got a stream of water running out of here of the tap. Now water, for those who do chemistry, is a polar solvent. It's made of oxygen and hydrogen. Oxygen wants the electrons more, so oxygen has a bit of a negative charge, hydrogen has a positive charge. So in a sense, there's this charge that's within the water. And what we can do with this balloon is we can charge it up with the old rub it on the hair. So we end up with an excess of charge. We create our electric field, if you like. I'm going to go into more detail of these. And then when we hold the balloon near the water, we can see how the balloon makes the water bend. Straight water, bring it closer, and we can bend the stream of water. If we want, bend it back this way as well. So once again, this is using charging by induction. It's a charge on the balloon, so if it's a positive charge on the balloon, that means all the positive charge in the water gets pushed to this side, the negative charge gets pulled towards the positive charge because opposite charges attract, and then because this side of the water, if you like, has a negative charge, that pulls the water towards the balloon. There we go.